Hey everyone, so today's notes are titled The Remainder Theorem and Factor Theorem. So let's go ahead and get started. So essentially the remainder theorem and the factor theorem are still connected with polynomials and more specifically dividing them. However, this theorem is a statement which allows us to use and get only the remainder from dividing two polynomials. So like again, refresher here in last time's notes, we were asked to divide these two polynomials with one another. We ended up getting 2x squared minus 11x plus 32 plus negative 93 over x plus 3. In this case, negative 93 was my remainder. In this case, negative 93 was my remainder. Essentially, the remainder theorem allows us to get this negative 93 without having to do all the synthetic division. And the reasoning for that is because there are times when you're working with polynomials that all you really care about is the remainder between the division of two polynomials, because that remainder can tell you a lot of important information. So today we're going to write out what the remainder theorem is and then use it to only find remainders of the division between two polynomials. So what is the remainder theorem? What does it say? So it tells us this. We're going to go ahead and get started. So the remainder theorem. It goes ahead and tells us this. Sorry, I'm going to disconnect my iPad from my... Okay, much better. So the remainder theorem, it tells us this. Let f be a polynomial function. If f of x is divided by x minus c, then the remainder is f of c. Okay, so we're going to go ahead and just so that I can show you what I mean, we're going to go ahead and use this same example over here, which we already know what the remainder is, negative 93. So we're going to copy it over. So 2x cubed minus 5x squared. Let's go into an example. 2x cubed minus 5x squared. What was it? Minus x plus 3 divided by x plus 3. Okay, so the way that we're going to go ahead and use this remainder theorem is like this. So we already obviously know that the remainder for this one is going to be negative 93. Now, the way that you're going to, what the remainder theorem tells you that you can do is that because I have a coefficient, because I have a, man, my iPad is not working with me today. Here we go. Because I have a degree of 1 and a coefficient of 1, I can go ahead and use this remainder theorem. So it's going to look like this. I'm going to take my polynomial of 2x squared minus 5x squared minus x plus 3, and I'm going to go ahead and substitute in the 0 value of this. And what is the value of x here? Well, by using the 0 property, I get x is equal to negative 3. So I'm going to go ahead and substitute in negative 3 into this equation. Into this expression. And then you're going to see how we are going to get that remainder. So go ahead and I'm going to do this, type it in onto my calculator to show you guys what the output is. I will be using Desmos to do that input. So let me go ahead and type it. So it is going to be 2 parentheses negative 3, close that parentheses, raised to the exponent of 3, and then what was the rest? Minus 5, open parentheses, negative 3, close those parentheses, squared, minus parentheses, negative 3, close those parentheses, plus 3. And what did we get as our answer? Negative 93. So all of this evaluates out to negative 93, which tells us that that is the remainder when we divide these two polynomials. So again, all the remainder theorem does is give you the remainder when you are asked to divide two polynomials together. And again, the reason why that is important, it will come next when we go over the factor theorem. So just for another example purpose, we're going to go ahead and do another one. Let's say if I give you f of x is equal to x cubed minus 4x squared minus 5, and I want you to go ahead and divide this by x plus 2. So in this situation, I am going to go ahead and input a value of negative 2 into my polynomial. So this would be negative 2 cubed minus 4 times negative 2 squared minus 5. Input that onto your calculator, which will give us parentheses negative 2 cubed minus 4 parentheses negative 2 squared minus 5. That goes ahead and gives me an output of negative 29. So what does that mean? That means that when you divide this polynomial by this polynomial, you will have a remainder of negative 29. So you can say that the remainder is negative 29. And I promise you, if you were to do this long division off to the side, or you can even use synthetic, you would see that negative 29. Okay, so the remainder theorem, it's important whenever you're asked to only find the remainder between dividing two polynomials. Okay, so this is now going to go ahead and lead us into the factor theorem. The factor theorem tells us this. One second. Okay, let f be a polynomial function. So we're still working with only polynomials here. So let f be a polynomial function. Then x minus c is a factor of f of x if and only if f of c is equal to 0. Now, there is two separate statements that are going on here because this is an if and only if statement. So I'm going to go ahead and lay out those two statements for you guys. So the first statement says this: if f of c is equal to 0, then x minus c is a factor of f of x. That's the first statement. That's the one that goes like in one direction. Now, the other direction of our if and only if statement tells us this: if x minus c is a factor of f of x, then f of c is equal to 0. Okay, so that's what if and only if statements pretty much tell you. They go in both directions. And the factor theorem is super important because finding the factors of a polynomial is one of the most frequently asked things when you're working with them. Obviously, if I, like, the most common polynomial that you guys have probably worked with in the past are quadratics. Like, for example, you don't have to write this, but just to like refresh our memories, like if I give you x squared plus 4x plus I'm trying to think here. Or let's see, x squared plus 6x plus 8, right? And I wanted you to go ahead and factor this polynomial. This is easy to do, right? Because, oh my gosh, excuse that notification. This is easy to do because obviously it's a quadratic. You guys know multiple ways to find the factors or how to solve a quadratic, right? You guys can do the x method, figure out what are two numbers that multiply to 8 but add up to 6. If that didn't work, you guys know that you can use the quadratic formula to also go ahead and solve this, right? So on and so forth. I'm not going to write it all out. But yeah, whenever you're working with like a quadratic, there's a lot of ways that you guys know to go ahead and solve and find the zeros of that polynomial. Last time when we were going over the factoring worksheet, these were also all different types of polynomials and special cases to go ahead and factor them to then solve for the zeros, right? You set them equal to 0, and then those would be the points where the polynomial crossed the x-axis, the solutions. Now, whenever even more complex polynomials are given to you and using, the quadratic formula or like the special factoring cases don't work, the factor theorem is a good way to figure out what's a zero, what's a solution to a polynomial, okay? So I'm going to go ahead and kind of show you like an example of what I mean by this. So essentially, if you are ever given a polynomial and you get a remainder of 0, then you know that that expression that they asked you to divide by is a factor to your polynomial. So let's go ahead and do an example. Let me go ahead and say that, for example, if I give you f of x is equal to 2x cubed minus x squared plus 2x minus 3. And I wanted you to first figure out if A is x plus 2 a factor. And then we'll go ahead and we'll do B is x minus 1 a factor. Okay, now the way that you're going to do that is, like I said, use this theorem. It pretty much tells you if you use the remainder theorem and you get a remainder of 0, then you know that polynomial that you're dividing by is indeed a factor. So let's go ahead and let's try it with part A. So is x plus 2 a factor? Well, let's first figure out what's our value of x that makes this equal to 0, and in this case it's -2. So I'm going to go ahead and substitute in -2 into this polynomial, and make sure you be very careful when you're substituting in. I'm going to go ahead and use Desmos, so this will be 2 open parentheses, -2, close those parentheses, squared. Oh, no, sorry, cubed. Let's delete. And let's change that to cubed. -2 squared plus 2 open parentheses, -2. Sorry, I put 3. -2, and then my last one is -3. So in this case, I go ahead and get -27. So since my remainder does not equal 0, x plus 2 is not a factor, because the factor theorem, again, it tells you if f of c is equal to 0, then x minus c is a factor. And in this case, when I go ahead and substitute in my value of -2 here, I do not get 0, so it's not a factor. Let's try this one now. So in this case, my x value is 1. So let's go ahead and let's substitute in 1. So that'll be 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. Go ahead and substitute it onto your calculator. Remember, you can also do this algebra in your head, whatever you prefer. Sorry, I'm going to go ahead and keep this, and I'm just going to change my input. So my input there was now a 1. So let's change this to a 1. Let's change this to a 1. I go ahead and I get 0. So since this one is equal to 0, we do know, so since f of 1 equals 0, x minus 1 is a factor of the following polynomial, because my remainder is 0. Now that you know that it is a factor, you can go ahead and use synthetic division to divide them and figure out the factored form of the polynomial. On your guys' homework for this assignment, for these sets of notes, you will not have to do this extra step, but I am just going to show you because it is a preview to what we're going to be learning next. So like very quickly, actually, I'm looking at the time. We've already been taking notes for about 20 minutes. So you know what? I'm going to actually stop here for the homework assignment. If you, essentially, you guys are going to see, they're going to give you two polynomials, and they're going to ask you to first find the remainder, and then using the factor theorem, determine whether or not this expression is a factor. And that's all you got to do is, first of all, find the remainder, and then if your remainder is 0, then you can describe it that yes, it is a factor. If it's not, then all you would do is state that it's not a factor, however, or because the remainder is so-and-so number. Okay, we're going to go ahead and stop it here. Next time when we take notes, we'll take it one step further, because once you know that a polynomial is a factor, like what we had in part B, then you can go ahead and use this expression and this to do some more division and to essentially find the roots or the solutions to the polynomial. Okay, but we'll hold that off for next time. If you have any questions, make sure you ask. If not, thank you for copying down these notes.